Okay, so today we want to look at a different model than what we've looked at in the past. So remember what we've seen so far. In the Ricardian model, where we end up in a situation where each country specializes fully, everybody in the economy is better off. They've got a higher purchasing power, and the economy has an expanded set of consumption possibilities. So there are no losers from international trade. In the Hesher-Ohlman model, once we expanded it to more than one resource, we saw that international trade, again, continues to expand consumption possibilities. So the economy is still on a higher country indifference curve and a higher level of aggregate economic welfare. But we also saw that through that process of international trade, the owners of the abundant factor would actually gain from international trade, while the owners of the scarce factor of production would actually lose. That is, we would see a relative increase in the relative returns to the factor of production that the country was relatively abundant in. Well, what we're going to do today is extend this a little bit further. And now we're going to consider two different things that we haven't looked at before. One is we're going to expand it to 3 factors of production rather than just 2. And now we're also going to change our assumption about factor mobility. Remember, up to this point, we've been making the assumption that factors are freely and costlessly mobile between industries within the economy. So now we want to think about, well, what happens if they're not? What happens if they're not? So that then will lead us into what is known as the specific factors model. So, of course, that brings the question, what actually... Okay. Bad battery. Okay. So that brings us to the issue of what exactly is a specific factor? Okay. So again, remember, we've been making the assumption, or working with the assumption, that factors of production were costlessly and freely mobile between industries. So that would be, obviously, a mobile factor. But it turns out that some factors of production are not particularly mobile in the short run. That is, it's difficult to transfer the factor of production from one industry to another. Now, what that actually means, then, in terms of the factors of production themselves, might be different for different industries. So, as an example, we typically think of labor as being a relatively mobile factor of production. Generally, workers can move between industries pretty easily. But not all workers can move between industries pretty easily. In fact, the more highly skilled, the more highly educated and skilled you are with a narrower and narrower focus, the harder it will be to actually move between industries, and at least move in a way that you can sustain the income that you have earned. It may also be the case that if you're in a very low-skilled industry, and the other industries that are expanding are high-skilled industries, that you're going to find it very difficult to move out of that low-skilled industry into a higher-skilled industry. So labor can be relatively immobile, but of the factors of production that we typically think of, labor generally is the most mobile of the factors of production that we have. Capital equipment, the physical machines that we make things with, also have some degree of mobility, but also some degree of immobility. So if we thought about the types of factors of production that we would call capital equipment that are used in many industries, things that might include things like computers and routers and wireless communications networks, all that kind of high-techy stuff, a lot of that stuff could easily be moved from one industry to another. And so it would be considered a mobile resource. But again, the more specific that factor of production, that particular piece of equipment, the less likely it is to be able to be transferred to a different usage. Finally, things like structures, big capital structures. Think about a steel mill or an automobile factory or a power generation facility. Once you've built it, it's built typically for a very specific purpose. And it would be very difficult then to transfer those resources into another usage. And therefore, you might end up with that factor being specific to that industry for a very, very long period of time. So just to give you an example, something that's been in the news over the last couple of years, as the U.S. auto industry has been shrinking, one of the things General Motors, Ford, and Chrysler have been doing is closing down assembly facilities and manufacturing plants around the country. So we've even had that happen down here where General Motors and Toyota decided to close down the NUMMI facility in Fremont. So auto manufacturing facilities have a tendency to be pretty specific to making and assembling automobiles. There's not a lot of other things that all of a sudden can be put into those types of facilities. So that would give us an example then of a type of factor of production that would be very specific to that industry. And just to give you an idea of how bad some of this can be, on the east side of Detroit, there is an auto assembly plant that was used by the DeSoto Motor Company. How many of you ever heard of DeSoto Motors? Okay, one. Okay, that's probably about right. Most people have never heard of or even seen a DeSoto. This facility still lies abandoned today. It was closed in 1958. So here we are, big piece of land, lots of buildings, just sitting there. Those factors of production, the land itself, the facilities, the money that was captured in building all of those facilities are locked in, cannot be transferred. So we need to think then about how we can deal with factors of production that are relatively mobile, as well as factors of production that are relatively specific to certain types of economic activity. So that's what we want to look at now. We'll start with thinking about, again, our set of assumptions. 2 countries, in this case the US and Japan. We're going to have 2 products, automobiles and food. We'll have 3 factors of production, labor, capital, and land. The assumptions that we'll make about our factor mobility are the following. Labor is mobile between the industries within the country. Capital is specific to the auto industry. And land is specific to the agricultural or food industry. Now, when we talk about a resource like land being specific to the food industry, we're not saying that no land is ever used in the automobile industry. It clearly can be. But again, most of the land is going to be captured as having a specific purpose for an individual industry. So when we think about the production function for automobiles, well, we've got 2 factors of production, and it will depend upon how much labor and how much capital we're using. So notice that in this particular production function, even though the economy has 3 factors of production, labor, capital, and land is not a relevant input into the production of automobiles. So when we write our production function, we only have output as a function of capital and labor. Food, of course, is not going to be dependent upon labor and land. So capital is not a particularly important resource in terms of food production in this model. So again, our production function for food includes land and labor, but not capital. It's not a particularly important feature. Our production possibilities frontier will still have the same general shape that we've seen before with production possibilities frontiers. It will be bowed. So notice by being bowed, we're assuming that the marginal productivities of the factors of production are not constant, or rather we have diminishing marginal product of capital and diminishing marginal product of labor. The slope of this production function at any point is the tangency, the slope of the tangency, it would be the marginal product of labor. I don't know if we can say that. Since we have more than one factor of production. Not important for what we're going to do. Okay. The first thing that we need to think about now is we know that all capital is confined to the automobile industry. Capital is specific to automobiles. We know all the land is confined to the agricultural industry because we assume the land was specific to the food industry. But labor is mobile between the two industries. So what we need to determine how much labor is actually working in the automobile industry and how much labor is actually working in the food industry. What's the allocation of labor that takes place? So let's assume, though, as we have been, that again, the labor supply is fixed and mobile. Now we need to think about the demand for labor to figure out what that allocation is. And the demand for labor in any sector will depend upon the price of the output in that sector and the marginal product of labor in that sector, as well as the wage rate in that sector. So notice that the price of automobiles, for instance, times the marginal product of labor in automobiles will give us the value of our marginal product, which in a competitive economy, a competitive labor market, should equal the real wage. Same thing is true in the food industry. The price of food times the marginal product of labor in the food industry gives us the value of the marginal product of labor. And the equilibrium condition for hiring workers then will be hire workers up to the point where the value of the marginal product of labor is equal to the nominal wage. So again, for each of the industries, this is our equilibrium condition for hiring. So we want to hire the number of workers where the value of their marginal product now equals the nominal wage. Now remember, we've already assumed that labor is mobile between the two industries. So just like we had in the Ricardian model, something is going to fall out. Wage rates have to be the same in the two industries. Right? Otherwise, workers will move to the other industry just to work for the higher wage. And as they do, they'll drive that wage down and the wage higher in the other industry. So we can look at what these relationships are. Here's the value of the marginal product of labor, and here's the amount of labor. Because we have diminishing marginal product of labor, and we assume for now that we have a fixed price of automobiles, the value of the marginal product of labor will be downward sloping. So this is the price of automobiles, a fixed given price, times the marginal product of labor in the auto industry. So again, if we have a given price for automobiles and the marginal product of labor in the auto industry declines as we hire more and more workers, this is what the value of the marginal product of labor will look like. It's very easy to see that if the wage rate in the auto industry is very high, then the amount of workers that we are going to hire is going to be quite low. And similarly, if the wage rate falls, we would expand the amount of employment that we would have in the industry. This value of the marginal product of labor curve is also our demand for labor curve. In the auto industry. Again, not terribly surprising, right? Lower wage rates are everything else given. At a lower wage rate, you're going to hire more workers than you are at a higher wage rate. So that's really all that we've shown here. We can do the same thing for the food industry, and of course we would see exactly the same thing. We've got the price of food, a fixed given price, times the marginal product of labor in the food industry. And that then gives us our demand for labor curve in the food industry. High wages, we're not going to hire very much. The demand for labor will be low, and lower wage, the demand for labor will increase. Once we have these two demand for labor curves, we can now figure out the allocation of labor between the food and auto industry. And we do that through something that looks like, but is not, an Edgeworth box. Only looks like it, but you'll notice that there's no top to this particular box. So a couple of things that we can see here. In the lower left-hand corner is the origin for the automobile industry. Running across the horizontal axis is the total labor supply for the economy. So as employment in the auto industry increases, we're moving from left to right. Now, whatever workers don't work in the auto industry have to work in the food industry. Remember, we not only have a fixed labor force of this amount, but we're also assuming the labor force is fully employed. So in the lower right-hand corner, we have the origin for the food industry. So increasing employment in the food industry actually moves from right to left. So where we divide along this horizontal axis is going to give us the allocation of labor between the two industries. So if we're way back here, not very many people in autos, a lot in food. We're here, a lot of people in autos, not very much in food. So that's our horizontal axis. The vertical axes are simply the value of the marginal product of labor and the nominal wage rate. Auto industry on the left, food industry on the right. So now let's put in our demand for labor curves. In the auto industry, we have the price of automobiles times the marginal product of labor in autos. So there's our demand for labor curve. Now for the food industry, remember the axis or the origin is sitting on the right-hand side. So we're basically reversing the way the diagram would look. So here for the food industry, we would see the value of the marginal product as downward sloping, but again from right to left. Notice that we have a given price for food and a given price for automobiles. The equilibrium allocation of labor will end up being where the wage rate is equal in both industries, so there's no incentive for workers to migrate from one industry to the other. So we get OA, LA workers in the auto industry and OF, LF workers in the food industry. Now you might note that if we had a change in the price of food, the price of automobiles, the marginal product of labor in the auto industry, or the marginal product of labor in the food industry, then one of these two marginal product curves is going to have a different position. It'll shift. And then we'll get a different equilibrium nominal wage, and we'll get a different allocation of labor. So this particular allocation of labor that I've drawn is dependent upon these two marginal product of labor or demand for labor curves looking as they do as I drew them, which may or may not actually be the case. So this is, by the way, part one of the specific factors model. So part one, of course, means that there's more than one part. So when we're thinking about this allocation of labor and how it influences the rest of the economy, we also need to think about what's happening with the specific factors. So let's look then at the specific factor of capital. So we want to figure out what the capital owners actually earn. That is, what's the rental rate on the capital that they're supplying. So again, supply and demand. So we're going to assume that we're fixed supply of capital, but it's also very specific to the auto industry. Now we also need to think about the demand for capital. Again, it will be dependent upon the price of autos and the marginal product of capital in the auto industry relative to the nominal cost of renting capital, R sub K. Once again, notice that the product of the first two of these will give us the value of the marginal product of capital in the auto industry. So on our horizontal axis, we've got the capital that's available to the auto industry. Now, for the supply side, this is really easy. Remember, we assumed that the amount of capital was fixed. And it's specific, so it can't move around the way labor can. So when we think about the supply of capital, we simply have a vertical line. So let's call that K bar for fixed. Now we want to think about what the value of the marginal product of capital is. Well, once again, we know that we're starting with a fixed price of automobiles, and we have diminishing marginal returns to capital in the auto industry. So the value of the marginal product of capital will also be downward sloping. Here is our demand for capital in the auto industry. Well, we've got our demand curve, we've got our supply curve. The intersection point must be worth something. So this intersection point then gives us our equilibrium rental rate for capital. So this tells us then the return to capital that the owners of capital are earning. They've got a fixed amount of capital, K bar, and they're earning 0 to R sub K rent on each unit. So this area in here is capital income. Again, notice that if the price of autos changes, or for some reason the marginal product of capital in the auto industry changes, this demand for capital curve is going to be in a different location, which is also going to change the rental rate on capital, or the return to the capital owners. Something we'll come back to in just a minute. This is part two.